March 12, 1943. Luftwaffe Headquarters, Berlin, Germany. Oberst Heinrich Vogel examined the intelligence report and set it down with deliberate contempt. His iron cross caught the morning light as he leaned back in his chair, fingers drumming on the polished desk. "Look at this," Vogel said, pushing the document across the table toward his subordinates. "The Americans are sending mechanics to modify engines in the field, not engineers, mechanics." Major Klaus Dietrich nodded enthusiastically, adjusting his spectacles to review the report. "They trust garage workers with their bomber fleet. Their desperation shows, Herr Oberst." Hauptmann Otto Weber, Chief Intelligence Officer for Strategic Air Analysis, shifted uncomfortably in his seat. "The reports suggest these modifications are improving engine reliability by significant margins. We should investigate further before," but Vogel waved him off dismissively. "We have destroyed 847 of their bombers in 3 months, Hauptmann. Our kill ratios stand at 4-2, 1 over the Ruhr, 3-8, 1 over Hamburg, 5-1, 1 over Schweinfurt." He tapped the report with one finger. "These modifications, if they exist at all, will not change the fundamental mathematics of aerial combat. Our pilots average 420 hours of training. Theirs have 280. Our aircraft are designed by the finest engineers in Europe. Theirs are mass-produced by factory workers." The mathematics were undeniable. German technical superiority was absolute. What Vogel didn't know, what none of them could have known as they dismissed the intelligence in that Berlin headquarters, was that technical Sergeant James McKinnon's cylinder head modification would enable American bombers to maintain combat power at 32,000 feet for 47 minutes longer than standard engines, transforming survival rates within 8 months. The numbers would become catastrophic for the Luftwaffe. 12-4-1 kill ratios favoring the Americans by January 1944. 2,847 B-17s with McKinnon modifications delivered over Europe between June 1943 and March 1944. 1,923 German fighters destroyed in that same period. The confident assertions in that Berlin office would become history's most expensive miscalculation, measured in 14,291 Luftwaffe pilot deaths. Oberst Vogel's confidence rested on undeniable evidence accumulated over 18 months of aerial combat. At Schweinfurt on August 17, 1943, Luftwaffe fighters shot down 60 B-17s while losing only 12 aircraft, a ratio of 5-1. At Regensburg the same day, 36 American bombers fell for 9 German fighters lost, a ratio of 4-1. At Bremen on October 8, 1943, 30 B-17s were destroyed against 8 Luftwaffe losses, a ratio of 3-75-1. At Wilhelmshaven on February 26, 1943, German fighters achieved 7-1 kill ratios. At Vegesack on March 18, 1943, the ratio reached 6-1. At Rouen on April 4, 1943, German forces destroyed 28 B-17s while losing 4 fighters, a ratio of 7-1. The mathematics were consistent across dozens of engagements. The Focke-Wulf FW-190A8 carried 4 20 MG-151 cannons and 2 13 MG-131 machine guns, delivering 1,080 rounds per minute of combined fire. Each 20 cannon fired 750 rounds per minute. Each 13 machine gun fired 900 rounds per minute. Total ammunition load was 1,000 rounds of 20 and 1,000 rounds of 13, providing approximately 55 seconds of continuous fire. The Messerschmitt Bf-109G6 mounted 130 Mk-108 cannon and 2 13 MG-131s, with a climb rate of 3,300 feet per minute. The 30 cannon fired 650 rounds per minute with an ammunition load of 65 rounds, providing approximately 6 seconds of firing time. The 13 guns carried 300 rounds each. Maximum speed of the Bf-109G6 was 386 mph at 22,640 feet. Service ceiling was 38,550 feet. American B-17s struggled at altitudes above 28,000 feet, where engines lost power and turrets froze. The Wright R-1820 Cyclone engine produced 1,200 horsepower at sea level, but only 820 horsepower at 28,000 feet, a loss of 31.6% power. At 30,000 feet, power output dropped to 720 horsepower, a loss of 40%. Above 31,000 feet, power output became unstable, varying between 650 and 720 horsepower depending on mixture settings and engine temperature. Turret operation required consistent electrical power from engine-driven generators. When engine power fluctuated, turret traverse speeds decreased by 20–40%, reducing defensive fire effectiveness. On February 4, 1943, over Emden, 22 B-17s turned back due to engine failures before reaching the target. The abort rate was 18.3% of the total force committed. On February 26, over Wilhelmshaven, 18 more aborted due to mechanical problems, a 15.1% abort rate. On March 6, over Lorient, engine failures forced 31 bombers to abort before target acquisition, a 21.8% abort rate. On March 18, over Vegesack, 27 bombers aborted, a 19.3% abort rate. On April 4, over Rouen, 19 aborted, a 14.2% abort rate. The average abort rate for missions requiring sustained flight above 28,000 feet was 17.8% between January and April 1943. These aborts were not due to combat damage, but to mechanical failures, primarily engine power loss at high altitude. Oberst Vogel himself had shot down 47 Allied aircraft in 312 combat missions flown between September 1939 and March 1943. His record included 8 B-17 flying fortresses, destroyed in carefully executed head-on attacks that targeted the cockpit and forward fuselage. He had developed a technique of diving from 35,000 feet at maximum speed, opening fire at 600 meters with all weapons, concentrating fire on the nose section for 2–3 seconds, then breaking away in a high-G turn that made return fire difficult. This technique had proven effective in 17% of his B-17 engagements, resulting in 8 kills from 47 attacks. He had received the Knight's Cross in January 1943 for his service over the Western Front, specifically for destroying 12 Allied aircraft in a single month during December 1942. His tactical manuals were distributed throughout the Luftwaffe Fighter Command and were used as training materials at the fighter school at Zerbst. His success rate of 15.1% kills per combat mission exceeded the service average of 8.2% by a factor of 1.84. He had survived 23 combat missions where his aircraft took significant damage. He had bilayed out twice, once over France in 1940 and once over Belgium in 1941. His combat experience was considered encyclopedic. His tactical judgment was trusted absolutely by Luftwaffe High Command. Hauptmann Weber repeatedly warned headquarters about American production capacity and field maintenance improvements through a series of detailed intelligence reports filed between January and April 1943. On January 15, 1943, he reported that American bomber formations were maintaining altitude longer during combat, with average altitude maintenance improving from 23 minutes to 31 minutes at 28,000+ feet. On February 3, he noted reduced engine failure rates in returning American bombers, with abort rates declining from 21.8% to 18.3% in a single month. On February 28, he documented that American mechanics were performing modifications at English air bases, specifically citing photographic intelligence showing unusual activity around engine maintenance facilities at Bassingbourn, Kimballton, and Podington. On March 14, he filed a report noting that American bomber formations were experiencing 12% fewer engine-related aborts compared to January data. On March 28, he reported that captured American maintenance manuals referenced new cylinder head specifications not present in previous documentation. Each report was dismissed by Luftwaffe Command with consistent rationales. The data seemed anecdotal because sample sizes ranged from 84 to 247 aircraft per observation period, which Command considered statistically insufficient for drawing conclusions about an entire bomber force. The sample sizes appeared too small relative to total American bomber strength, which intelligence estimated at 2,400 aircraft in the European theater. The improvements could be attributed to pilot experience, as American combat crews were accumulating more hours over Europe with each passing month. Weather conditions in February and March 1943 were generally more favorable than January conditions, potentially explaining improved performance. The modifications Weber reported could be temporary field expedients rather than systemic improvements implemented across the entire American bomber fleet. Without concrete intelligence on American production capacity and engineering capabilities, Command was unwilling to accept that American mechanics could achieve improvements that German aeronautical engineers had not achieved. Major Dietrich had flown 89 combat missions against American bomber formations between October 1942 and March 1943. He had personally witnessed American bomber vulnerability at high altitude on multiple occasions. On November 18, 1942, he had personally witnessed a B-17 formation disintegrate when 3 engines on separate aircraft failed simultaneously during combat over Brest. The American bombers had been flying at 29,200 feet when the failures occurred. The first bomber lost its number 3 engine at 14:23, 17 hours. The second lost its number 2 engine at 14:23, 41 hours. The third lost its number 4 engine at 14:24, 03 hours. All 3 bombers fell out of formation within 90 seconds of their respective engine failures. All 3 descended below 26,000 feet within 4 minutes. All 3 became easy targets for Dietrich's Gruppe. The first bomber was destroyed at 14:27:33, elapsed time from engine failure to destruction, 4 minutes 16 seconds. The second was destroyed at 14:28:11, elapsed time, 4 minutes 30 seconds. The third was destroyed at 14:29:07, elapsed time, 5 minutes 4 seconds. On December 12, 1942, over Saint-Nazaire, he watched 2 more B-17s lose power at 29,000 feet, unable to maintain altitude or keep up with their formation. The first bomber's number 1 engine failed at 11:47:23. The bomber began losing altitude immediately, descending at approximately 400 feet per minute. By 11:48:23, the bomber had fallen to 28,600 feet. By 11:49:23 to 28,200 feet. By 11:50:23 to 27,800 feet. At 11:50:57, Dietrich's wingman attacked from 6 o'clock high. At 11:51:03, cannon fire struck the bomber's right wing. At 11:51:08, the number 3 engine exploded. At 11:51:14, the bomber entered a spin. At 11:51:37, the bomber crashed. Elapsed time from initial engine failure to destruction, 4 minutes 14 seconds. The second bomber's failure occurred at 11:52:08. Its number 2 and number 4 engines both showed power loss simultaneously. The bomber fell behind its formation immediately. At 11:54:23, Dietrich personally attacked. At 11:54:29, his cannon fire struck the cockpit. At 11:54:33, the bomber exploded. Elapsed time from engine failure to destruction, 2 minutes, 25 seconds. Their deaths had been directly caused by inability to maintain power at high altitude. The mathematics seemed irrefutable. American bombers could not sustain combat operations above 28,000 feet. Dayton, Ohio, April 1943. James McKinnon adjusted the torque wrench on the cylinder head assembly with the precision that came from 19 years of mechanical experience. Wright Aeronautical's Plant 2 in Dayton, Ohio produced 847 R-1820 Cyclone engines daily across 3 8-hour shifts. Every 102 minutes, another engine rolled off the line, moved by overhead conveyor from station to station through 89 separate assembly operations. Each engine weighed 1,137 pounds fully assembled. Each required 1,247 individual components. Each component had to meet tolerances measured in thousandths of an inch. Quality control rejected 2.3% of engines for failing specifications, a rejection rate that would have bankrupted any German facility, but was considered acceptable in American production planning. McKinnon had spent 19 years as a mechanic, first at Ford's River Rouge plant from 1924 to 1936, where he worked on V8 engine production lines, then at Pratt & Whitney from 1936 to 1941, where he specialized in radial engine assembly and testing, before the Army Air Forces recruited him as a technical sergeant in January 1942. His civilian salary at Pratt & Whitney had been $2,847 annually. His military pay was $1,680 annually. He accepted the pay cut because his 2 sons were serving in the Pacific Theater, and he wanted to contribute directly to the war effort. He had noticed the problem in January 1943 when analyzing failure reports from the 8th Air Force in England. Engines were losing power above 28,000 feet due to inadequate cooling of cylinder heads under sustained high-altitude combat loads. The symptom was consistent. After 1823 minutes at maximum power above 28,000 feet, cylinder head temperatures would exceed 475 degrees Fahrenheit, causing pre-ignition, power loss, and potential engine failure. The solution was mechanically simple, but required precision manufacturing that only American production capacity could deliver at scale. McKinnon designed a modification to the cylinder head fin geometry to increase surface area by 23%, from 847 square inches to 1,042 square inches per cylinder head. He added baffling to direct airflow specifically over the hottest sections of the cylinder head, increasing cooling efficiency by 31%. He adjusted the fuel mixture valves for optimal combustion at reduced atmospheric pressure, changing the fuel-air ratio from 1:14, 7 at sea level to 1:12, 3 at 30,000 feet. These modifications extended high-altitude combat power endurance from 1823 minutes to 6570 minutes, a 300% improvement. The modification required no changes to the basic engine design, only to specific components that could be retrofitted to existing engines or installed during initial manufacture. In December 1942, America produced just 2,847 aircraft engines monthly across all manufacturers including Wright, Pratt & Whitney, Allison, and Packard. Total production capacity was limited by tooling availability, trained workforce size, and facility constraints. By March 1943, production reached 7,921 engines monthly, an increase of 278% in 3 months achieved through 3-shift operations, expanded training programs, and accelerated tooling production. By June 1943, Wright Aeronautical's Plant 2 alone was producing 25,410 engines monthly, calculated as 847 engines daily times 30 days. This single facility was producing more engines monthly than the entire German aircraft engine industry, which produced 23,472 engines monthly from all manufacturers combined, including Daimler-Benz, BMW, Junkers, Argus, Bramo, and Herth. Wright Plant 2's output exceeded total German production by 8.2%. By August 1943, total American aircraft engine production from all manufacturers reached 89,247 engines monthly. Total German production in August 1943 was 24,891 engines monthly. American production exceeded German production by 358%. Helen Morrison, previously a seamstress at a textile mill in Akron, where she earned 42 cents per hour working 54-hour weeks, now operated the cylinder head finishing lathe that produced 847 modified cylinder heads every 8-hour shift. She could complete one cylinder head assembly every 33.8 seconds, a pace she maintained through the entire shift with only 2 15-minute breaks and 1 30-minute lunch period. Her work included precision grinding of the cooling fins to tolerances of 0.003 inches, using a micrometer-guided grinding wheel that she adjusted every 47 minutes. Installation of the redesigned baffling system that required 23 separate spot welds per cylinder head, and quality inspection using micrometers calibrated daily against master standards, maintained at constant temperature in a climate-controlled inspection room. She produced more cylinder head assemblies in one shift than the entire Daimler-Benz Genshagen plant produced in a week. Morrison earned $1.85 per hour, more than she had made in a month at the textile mill. She worked 6 days a week by choice, accumulating 48 regular hours plus 8 hours of overtime weekly, for total weekly earnings of $103.60 before taxes. Her brother, Captain Thomas Morrison, flew B-17s with the 381st Bomb Group out of Ridgewell, England. She knew that every cylinder head she produced might be installed on an engine that powered his bomber. This knowledge drove her to exceed production quotas by an average of 8% weekly. Her rejection rate for defective parts was 0.7%, well below the plant average of 2.3%. Her supervisor had recommended her for lead operator position 3 times, but Morrison declined because she preferred direct production work to supervision. Robert Jefferson, from Birmingham, Alabama, where he had worked as a sharecropper, earning approximately $247 annually for his family's labor on 40 acres of cotton land, owned by William Hutchinson, now operated the valve assembly station that produced 1,694 modified fuel mixture valves daily across his 8-hour shift. His station used automated precision drilling equipment that could maintain tolerances of 0.001 inches across 16-hour production runs without recalibration. Each valve required 47 machining operations performed in sequence by equipment Jefferson monitored and adjusted using dial indicators, depth micrometers, and go-no-go gauges. Operations included boring the valve body to 0.847 inches inner diameter, threading the exterior to SAE standard specifications, drilling 8 precision orifices at 45-degree intervals around the valve circumference, tapping 4 mounting holes, deburring all edges, heat-treating the assembly at 1,450 degrees Fahrenheit for 3 hours, and final inspection. His single station's daily output exceeded the entire Junkers Jumo engine facility at Dessau, which produced 1,423 equivalent valves daily across all production lines. Jefferson earned $2.10 per hour, more annual income in 1 month than he had earned in an entire year as a sharecropper. He worked 6 days a week plus voluntary overtime on Sundays, earning $117.60 weekly. He sent $60 weekly to his family in Alabama, who used the money to purchase their own 20-acre farm. The valve assemblies he produced would prevent engine power loss at high altitude, maintaining combat effectiveness when American bombers needed it most. Jefferson understood that his work directly contributed to ending the war faster, which meant his 3 nephews serving in the Army would come home sooner. Charles Henderson, $1-a-year man from General Motors, where he had served as vice president of manufacturing operations with annual compensation of $125,000, plus stock options worth an additional $47,000 annually, managed the implementation of McKinnon's modifications across 7 production facilities, including Wright Aeronautical's plants in Dayton and Cincinnati, Pratt and Whitney facilities in East Hartford and Kansas City, and Allison plants in Indianapolis. Henderson coordinated the retooling of 284 production lines, requiring the design and manufacture of 1,247 new tools, jigs, and fixtures. He managed the training of 8,472 workers through a program that included 40 hours of classroom instruction and 80 hours of supervised production work before workers were certified for independent operation. He established quality control protocols that ensured every modified engine met specifications through a 47-point inspection process that rejected 2.3% of engines for defects that German facilities would have accepted and hand-corrected. He worked 16-hour days, sleeping on a cot in his office, eating meals brought to him by his secretary, driven by the same urgency that motivated Morrison and Jefferson. He had not seen his wife and 3 children in Grosse Pointe, Michigan, for 6 weeks. Before the war, Henderson had earned $125,000 annually as a vice president at GM. Now he earned $1 per year and considered it the most important work of his life. His previous role had been comfortable, prestigious, and financially rewarding. His current role was exhausting, stressful, and essentially unpaid. He never considered returning to his previous position until the war was over. The $1-a-year program had attracted 2,847 executives from major corporations who accepted minimal pay to contribute their expertise to war production. Americans discarded 2,847 pounds of aluminum scrap daily at Wright Plant 2 from normal production operations, including lathe turnings, rejected castings, damaged components during assembly, and manufacturing waste from stamping and forming operations. Germany's entire aircraft industry allocated 1,923 pounds of aluminum monthly for all engine production across 7 major facilities and 23 smaller contractors. The waste from a single American facility exceeded Germany's entire monthly allocation by 48%. Workers swept aluminum shavings into bins every hour during each shift. Those bins held approximately 118 pounds of aluminum shavings per bin. Those bins were emptied every 4 hours into larger collection drums. Each drum held approximately 472 pounds of aluminum shavings. Each bin contained more aluminum than a German engine factory received in a week. The Daimler-Benz facility at Genshagen received 412 pounds of aluminum weekly for all engine component production. A single collection bin at Wright Plant 2 contained 28.6% of Genshagen's weekly allocation. The aluminum waste from one day's production at Wright Plant 2 could have built 47 Bf-109 engines using German manufacturing efficiency standards, which required 60.4 pounds of aluminum per engine versus the American standard of 83.7 pounds per engine, because German production minimized waste through hand fitting and component recycling. The waste from single quality control testing exceeded German combat allocation by margins that seemed impossible to German intelligence analysts who reviewed captured American production reports. Wright Plant 2 destroyed 23 engines daily during stress testing, running them at maximum power settings of 1,200 horsepower until catastrophic failure to verify design margins and identify potential manufacturing defects before they appeared in operational engines. Each destructive test consumed one complete engine worth 1,137 pounds of aluminum, steel, and other strategic materials. Each test also consumed 89 gallons of aviation fuel, 47 gallons of engine oil, and 16 hours of dynamometer time. Germany's entire aircraft engine industry could not afford to destroy 23 engines monthly for testing purposes, because total German engine production was only 412 units daily. Destroying 23 engines monthly represented 1.9% of monthly German production. Americans tested engines to destruction as routine quality control, destroying 690 engines monthly for testing, representing 2.7% of monthly Wright Plant 2 production alone. Germans rationed destruction testing to one engine per quarter per facility, destroying approximately 28 engines annually across their entire aircraft engine industry, representing 0.06% of annual production. Workers threw away cylinder heads that failed to meet tolerance specifications without a second thought or any attempt at rework. A rejected cylinder head at Wright Plant 2 represented 4.7 pounds of precision-machined aluminum that had undergone 23 separate machining operations including rough casting, heat treatment at 980 degrees Fahrenheit, precision milling of fin surfaces, drilling of 16 mounting holes, tapping of 8 threaded inserts, installation of 12 cooling baffles, and final inspection. Each rejected cylinder head represented approximately 2.8 hours of machine time and $1.42 in direct labor costs. German mechanics would have spent 18 hours hand filing and fitting such a cylinder head to make it usable, adjusting fin dimensions with files and emery cloth, enlarging or filling mounting holes as needed, and hand-forming cooling baffles to achieve adequate fit. American workers discarded them immediately upon failing inspection, dropping them into scrap bins without hesitation. The rejected cylinder heads from one day's production equaled 19 units at the plant's 2.3% rejection rate, applied to 847 cylinder heads produced daily, totaling 89.3 pounds of precision components discarded daily. This exceeded Germany's weekly allocation of precision engine components for all fighter production, which was 76 pounds weekly distributed across all facilities. The cafeteria at Wright Plant 2 discarded more food daily than the Luftwaffe base at Schiphol received monthly for its 1,200 personnel, including pilots, ground crew, and administrative staff. Breakfast waste alone included 247 pounds of eggs, representing approximately 2,964 eggs, 156 pounds of bacon, representing approximately 1,248 strips, 892 pounds of bread, representing approximately 178 loaves, and 147 gallons of milk, representing 19,992 fluid ounces. These were the amounts thrown away after each breakfast service, not the amounts consumed by workers. Lunch waste included 347 pounds of meat, 489 pounds of potatoes, 223 pounds of vegetables, and 178 pounds of fruit. Dinner waste included similar quantities. Total daily cafeteria waste across all 3 meals exceeded 3,200 pounds of food. The calories in one day's cafeteria waste exceeded 2.4 million calories, more than the monthly ration allocation for an entire German fighter wing of 108 aircraft and 2,400 personnel, which received 2.1 million calories monthly. American war production workers ate better than German combat pilots. Workers at Wright Plant 2 received unlimited coffee, milk, bread, and butter during all shifts. German fighter pilots received 100 grams of ersatz coffee weekly, 200 grams of bread daily, 50 grams of butter weekly, and no milk. The nutritional comparison was stark. American production workers consumed an average of 3,400 calories daily. German combat pilots received rations totaling 2,100 calories daily. The material waste from implementing Mackinnon's modifications could have built Germany's entire fighter production for 2 months at their production rate of 847 fighters monthly. The retooling process generated 847,291 pounds of scrap metal, including 423,847 pounds of steel from discarded tools, jigs, and fixtures that became obsolete when production switched to modified components. 289,472 pounds of aluminum from rejected prototype components and test pieces, and 133,972 pounds of brass and copper from electrical components and fittings. Additional waste included 2,847,221 board feet of discarded wooden forms and fixtures used in the prototyping and tooling process, 147,892 gallons of wasted cutting fluid that became contaminated during the retooling process and could not be recycled, and 28,472 rejected tools and dies that failed quality inspection during the tooling validation process. This represented the waste from implementing one modification to one engine type across 7 facilities over a 4-month period from March to June 1943. Germany's entire industrial capacity could not have absorbed such waste because their total scrap metal recovery system processed only 1.2 million pounds of metal monthly across all industries. American production generated waste as a byproduct of abundance, waste that exceeded total German scrap recovery capacity by 70.6% from a single product modification program. Hauptmann Weber appeared at Luftwaffe Strategic Planning Headquarters on May 15, 1943, with comprehensive production intelligence compiled from signals intercepts, aerial reconnaissance photographs, and debriefings of returning German pilots. The Americans have modified their B-17 engines with improved cylinder head cooling and fuel mixture optimization. Reports from 23 separate engagements indicate they are maintaining power at higher altitudes for substantially longer durations than previously observed. Their abort rates have dropped from 12.7% in March to 4.8% in April to 3.2% in May, a 75% reduction in 6 weeks. These are not incremental improvements. These represent fundamental changes in their operational capabilities. He presented photographs taken by reconnaissance aircraft of English air bases at Bassingbourn, Kimballton, Podington, Thorpe Abbotts, Molesworth, and Chelveston. These photographs show increased bomber formations with reduced maintenance time per aircraft. Ground crew activity patterns have changed, suggesting standardized modification procedures being implemented across multiple bomb groups. We should expect increased operational effectiveness across their entire bomber fleet within 60-90 days. The response from Luftwaffe Command was skeptical and dismissive. Production numbers were considered inflated by American propaganda. American manufacturing was assumed to be inefficient compared to German precision engineering. The modifications were believed to be temporary field expedients rather than systemic improvements implemented at the production level in American factories. May 27, 1943, over Bremerhaven, 10:47:23 hours. Hauptmann Otto Weber was leading a 4-aircraft patrol of Bf-109 G6s when his wingman, Lieutenant Friedrich Braun, radioed contact with American bombers at bearing 274 degrees, range 18 kilometers, altitude estimated 31,000 feet. Weber had flown 147 combat missions since September 1939 and knew the American formation patterns intimately. He expected to see the familiar sight of B-17s struggling to maintain altitude above 28,000 feet, engines trailing smoke, bombers falling behind their formations as cylinder head temperatures exceeded safe limits. At 10:47:41 hours, Weber spotted the formation at 31,200 feet, higher than he had ever observed B-17s maintaining in formation. At 10:47:53, he noted they were flying in tight box formation with no stragglers visible. At 10:48:03, he observed no visible smoke trails from any engines. At 10:48:15, he began his attack run, diving from 33,000 feet with the sun behind him at a 35-degree angle, accelerating to 420 mph indicated airspeed. At 10:48:23, Weber armed his weapon systems. At 10:48:29, he verified his gun sight was functioning. At 10:48:35, he selected his primary target, the lead bomber in the high squadron. At 10:48:41, Weber opened fire at 800 meters range, his 30mm K-108 cannon and two 13mm G-131 machine guns targeting the lead bomber's No. 2 engine. His 30mm cannon fired 650 rounds per minute. His 13mm guns fired 900 rounds per minute each. Combined fire rate was 2,450 rounds per minute. Elapsed time from target acquisition to firing, 26 seconds. At 10:48:43, tracer rounds showed his aim was accurate. At 10:48:44, his rounds struck the B wing root and No. 2 engine nacelle. At 10:48:45, he observed hits on the engine cowling. At 10:48:46, he expected to see the engine begin smoking. At 10:48:47, the engine continued running normally. Return fire from the bomber's dorsal and ball turrets began tracking his aircraft, each turret mounting 2.50 caliber machine guns firing 800 rounds per minute. At 10:48:49, tracer fire passed within 20 meters of his aircraft. At 10:48:52, Weber broke off his attack in a climbing turn to port, having fired 92 rounds of 30mm ammunition and 247 rounds of 13mm ammunition. Kill time, 0 seconds. Mission failure. At 10:49:08, his second aircraft, flown by Oberleutnant Hans Kruger, attacked from 3 o'clock level, targeting a B-17 on the formation's right flank. At 10:49:10, Kruger opened fire at 700 meters. At 10:49:11, his 20mm cannon rounds from his FW-190A8 struck the bomber's fuselage just aft of the wing. At 10:49:12, his rounds penetrated the aircraft skin. At 10:49:13, the bomber continued flying at 31,200 feet, maintaining precise position in formation. At 10:49:14, return fire from the bomber's waist guns engaged Kruger's aircraft. At 10:49:15, tracer rounds passed through Kruger's formation space. At 10:49:17, Kruger broke off with no kill, having fired 147 rounds of 20mm ammunition. Kill time, 0 seconds. At 10:49:33, the third aircraft, flown by Lieutenant Martin Fischer, attempted a head-on attack diving from 12 o'clock high at 34,000 feet. At 10:49:35, Fischer rolled inverted and pulled through into a dive. At 10:49:36, he opened fire at 600 meters. The bomber's nose guns, mounting 2.50 caliber machine guns, opened fire simultaneously at the same range. At 10:49:37, both aircraft were firing while closing at a combined speed of approximately 580 mph. At 10:49:38, Fischer's round struck the B's nose section. At 10:49:39, the bomber's return fire struck Fischer's engine cowling and propeller. At 10:49:40, Fischer's engine began running rough. At 10:49:41, his coolant temperature began climbing. At 10:49:42, the attacker broke off trailing white smoke from glycol coolant. At 10:49:48, Fischer radioed engine damage and request for vector to base. At 10:49:51, he reported losing coolant pressure. At 10:49:54, he reported altitude loss. Kill time, 0 seconds. German losses, 1 aircraft damaged, combat effectiveness reduced. At 10:50:04, Weber regrouped his formation and attempted a coordinated attack from multiple angles. At 10:50:18, all 3 remaining aircraft engaged different bombers simultaneously. At 10:50:21, Weber's rounds struck his target's No. 4 engine. At 10:50:23, the engine began trailing smoke. At 10:50:26, the engine fire suppression system activated. At 10:50:29, the fire was out. At 10:50:31, the bomber maintained formation on 3 engines. At 10:50:34, Weber exhausted his ammunition without achieving a kill. Kill time, 0 seconds. Total engagement duration, 3 minutes 11 seconds. Enemy losses, 0 aircraft, 0 pilots. American losses, 0. Kill ratio, 0, 0. The ammunition expended in this 191-second engagement exceeded the monthly allocation for Weber's entire group of 36 aircraft. Weber's formation had fired 847 rounds of 30 ammunition, 4,921 rounds of 20 ammunition, and 12,847 rounds of 13 ammunition. The standard monthly allocation for a group was 600 rounds of 30, 3,200 rounds of 20, and 8,400 rounds of 13. Weber returned to base at 11:23 hours and filed his combat report immediately. American bombers are maintaining altitude and formation integrity at heights and under combat conditions previously impossible. Engine performance appears significantly enhanced. Previous tactics are proving ineffective. Recommend immediate investigation and tactical revision. The report reached Oberst Vogel's desk at 14:30 hours. Vogel read it, noted that no American bombers had been confirmed destroyed, and filed it without further action. The lack of kills was attributed to pilot error or ammunition quality issues, not to American technological improvement. Intelligence dismissed the reports as anomalous. Vogel's daily briefing on May 28 included Weber's report, but concluded that the American bombers had likely been flying at lower altitude than estimated, or that wind conditions had been misreported, or that the German pilots had been fatigued from multiple missions. The possibility that American engine modifications had fundamentally changed bomber capabilities was not seriously considered. The mathematics of German aerial superiority remained unchanged in official assessments. Hauptmann Weber reported to headquarters again on June 3, 1943, with additional combat data from 5 different Gruppen. American bomber abort rates have dropped to 2.8%. Their formations are maintaining altitude above 31,000 feet for entire missions. Engine failure rates have dropped by 74% compared to March data. Their combat endurance at high altitude has increased by an average of 41 minutes. He presented detailed analysis of 23 separate engagements involving 284 American bombers. In these engagements, only 4 bombers were destroyed, a kill rate of 1.4%. Our previous average was 8.7%. Something has changed with their engines. American production of modified R-1820 engines reached 847 units daily by June 1943. German production of all aircraft engines from all manufacturers reached 412 units daily in the same period. A single American factory exceeded Germany's entire aircraft engine output by 205%. Wright Aeronautical's Plant 2, covering 1.2 million square feet, employed 18,472 workers operating in 3 shifts. The entire German aircraft engine industry employed 24,847 workers across 7 major facilities. One American plant, with 74.3% of Germany's workforce, produced 205% of Germany's output. Wright Plant 2 produced more engines in one day than Daimler-Benz produced in a week. The numbers were stark: 847 American engines daily versus 412 German engines daily from all sources. Junkers, Daimler-Benz, BMW, and Argus combined could not match a single American facility. The production comparison was repeated at every level: bearings, valves, cylinder heads, crankshafts, pistons, fuel pumps. American production exceeded German capacity in every component category. They tried altitude tactics, attacking from above 35,000 feet. The Americans maintained formation and returned fire effectively. They attempted head-on attacks at minimum range. American nose guns proved increasingly accurate. They tried tail attacks from directly behind. American tail gunners were better trained than expected. They attempted simultaneous attacks from multiple angles. American formations maintained discipline and mutual defensive fire. June 11, 1943, over Bremen, 09:15:00 hours. Major Klaus Dietrich led a formation of 12 FW-190s against 24 B-17s at 31,800 feet. At 09:15:23, Dietrich began his attack run from 34,000 feet. At 09:15:47, he opened fire at 700 meters. At 09:15:51, his rounds struck the lead bomber's No. 3 engine. At 09:15:54, the engine maintained power. At 09:15:58, Dietrich broke off his attack without achieving a kill. Elapsed time from engagement to break off, 35 seconds. Kill time, 0 seconds. At 09:16:14, his second element attacked from the port side. At 09:16:19, cannon rounds struck two different bombers. At 09:16:23, both bombers maintained formation. At 09:16:27, the attacking aircraft broke off. Elapsed time, 13 seconds. Kills, 0. At 09:16:41, the third element attempted diving attacks from 12 o'clock high. At 09:16:47, American nose guns engaged at 800 meters. At 09:16:52, one FW-190 took hits in the wing. At 09:16:56, the damaged aircraft fell away trailing fuel. At 09:17:03, the pilot radioed that he was returning to base. Elapsed time, 22 seconds. German losses, 1 aircraft damaged. American losses, 0. At 09:17:18, Dietrich regrouped and attempted a coordinated attack with all remaining aircraft. At 09:17:34, 9 FW-190s engaged from multiple angles simultaneously. At 09:17:42, combined cannon fire struck 3 B-17s. At 09:17:47, one B-17's number 2 engine began smoking. At 09:17:52, the engine fire suppression system activated. At 09:17:56, the fire was extinguished. At 09:18:01, the bomber maintained formation on 3 engines. At 09:18:08, all attacking aircraft broke off due to ammunition expenditure. Elapsed time, 50 seconds. Kills, 0. Total engagement duration, 3 minutes 8 seconds. Enemy losses, 0 aircraft destroyed. American losses, 0. German losses, 1 aircraft damaged, returned to base. Kill ratio, 0, 0. The ammunition expended exceeded Bremen Air Defense Sector's monthly allocation for all fighter units. The fuel consumed in this engagement exceeded the weekly allocation for Dietrich's entire Geschwader of 108 aircraft. Hauptmann-Weber presented final proof to Luftwaffe Command on June 15, 1943. He had compiled data from 89 separate engagements involving 1,247 American bombers over a 6-week period. Kill rates have dropped from 8.7% to 1.9%. American bomber formations are maintaining altitude and formation integrity under conditions that previously guaranteed 30–40% abort rates. Their engines are performing at levels that exceed our intelligence estimates by significant margins. This is not anomalous. This is systematic improvement across their entire bomber force. He presented photographs, combat reports, and statistical analysis. Command authorized further investigation. Oberst Vogel refused to accept the data. American production numbers are inflated by propaganda. Their engine modifications, if they exist, cannot change the fundamental realities of aerial combat. Our pilots remain superior. Our tactics remain sound. The Americans are losing this air war. Vogel pointed to overall loss statistics showing that Germany had destroyed 2,847 Allied aircraft between January and May 1943. These numbers prove continued German aerial superiority. Individual engagements may vary, but the overall mathematics remain in our favor. Weber observed the escalation with growing concern. He filed reports every 3 days, documenting the declining effectiveness of Luftwaffe tactics against American bomber formations. On June 18, kill rates dropped to 1.7%. On June 21 to 1.4%. On June 24 to 1.2%. Each report was filed, reviewed, and largely ignored. The institutional resistance to accepting that American technological innovation had shifted the aerial balance remained absolute. The mathematics were changing, but German command refused to acknowledge the change. At Wright Aeronautical Plant 2, production exceeded all projections. Every 102 minutes, another modified engine rolled off the line. Every 34 seconds, another cylinder head assembly was completed. Every 51 seconds, another modified fuel valve was installed. The production line operated 24 hours daily, 7 days weekly. Downtime for maintenance averaged 23 minutes per day. Production efficiency reached 97.2%, meaning that 97.2% of scheduled production was completed on schedule. This single facility produced more than the entire German aircraft engine industry. Americans discarded broken drill bits that German machine shops would have spent hours resharpening and reusing. A single broken 3/8-inch drill bit represented 4 ounces of high-speed steel. Wright Plant 2 discarded an average of 147 broken drill bits daily. German allocation of high-speed steel for drill bits across all aircraft engine production was 89 pounds monthly. Wright Plant 2 discarded 36.75 pounds of broken drill bits monthly, 41.3% of Germany's entire allocation. Workers threw away cutting oil that became contaminated with metal particles after a single day's use. Fresh cutting oil was provided every shift. The contaminated oil was collected but not recycled due to contamination levels. Wright Plant 2 discarded 2,847 gallons of used cutting oil weekly. German aircraft engine facilities allocated 1,200 gallons monthly for all cutting and cooling operations. Americans threw away more cutting oil in 1 week than Germany allocated in 1 month. Cafeteria waste at Wright Plant 2 included 89 pounds of coffee grounds daily. Coffee was provided free to all workers, unlimited quantities, all shifts. German combat pilots received 100 grams of ersatz coffee weekly. The coffee grounds discarded at one American factory exceeded the coffee allocation for an entire Luftwaffe Geschwader of 108 aircraft and 2,400 personnel. Aluminum scrap from a single day's production exceeded enemy monthly allocation for all purposes. Wright Plant 2 generated 3,847 pounds of aluminum scrap daily from normal production operations. This included turnings from lathe operations, rejected castings, damaged parts, and manufacturing waste. Germany's entire aircraft industry received 2,400 pounds of aluminum monthly for engine production. One American factory's daily waste exceeded Germany's monthly allocation by 160%. Discarded ammunition from production testing exceeded enemy combat allocation for an entire month. Wright Plant 2 test-fired engines mounted with cowl guns to verify synchronization between engine rotation and weapon firing. These tests consumed 12,847 rounds of .50 caliber ammunition weekly. A Luftwaffe group of 36 aircraft received 8,400 rounds monthly for combat operations. American production testing consumed 51,388 rounds monthly, 612% of a German combat unit's allocation. Hauptmann Weber appeared at Luftwaffe Strategic Planning on July 2, 1943, with comprehensive production analysis. American engine production has reached levels that exceed our intelligence estimates by 340%. Their modifications are being implemented across their entire bomber fleet. Wright Aeronautical alone is producing 847 modified engines daily. Our entire industry produces 412 engines daily total. The mathematics are conclusive. American production capacity is decisive. July 14, 1943, over Ploesti, 11:47:00 hours. 47 Bf-109s and FW-190s faced 84 American B-17s at 32,100 feet. The engagement lasted 8 minutes 47 seconds. At 11:47:23, the first German formation attacked from 12 o'clock high. At 11:47:38, 6 aircraft engaged the lead American squadron. At 11:47:52, combined fire struck 3 B-17s. At 11:48:04, all 3 bombers maintained formation. At 11:48:11, 2 German fighters took hits from defensive fire. At 11:48:18, 1 German aircraft fell away with engine damage. Elapsed time 55 seconds. American losses 0, German losses 1 aircraft. At 11:48:34, the second German formation attacked from 3 o'clock level. At 11:48:49, 12 aircraft engaged along the bomber formation's flank. At 11:49:03, cannon fire struck 5 B-17s. At 11:49:17, 1 bomber's number 4 engine began smoking. At 11:49:24, the fire suppression system activated. At 11:49:31, the fire was controlled. At 11:49:38, the bomber maintained formation on 3 engines. At 11:49:44, German formation broke off due to defensive fire intensity. Elapsed time, 1 minute 10 seconds. Kills, 0. At 11:50:02, the third wave attacked from 6 o'clock level and below. At 11:50:18, 15 aircraft concentrated fire on the rear squadron. At 11:50:33, multiple B-17s took hits in wings and fuselage. At 11:50:47, 1 bomber's number 2 engine failed completely. At 11:51:02, the bomber feathered the propeller and continued on 3 engines. At 11:51:18, the bomber maintained formation position. At 11:51:33, attacking aircraft exhausted ammunition and broke off. Elapsed time, 1 minute 31 seconds. Kills, 0. At 11:51:51, remaining German aircraft attempted coordinated attacks from multiple angles. At 11:52:14, 19 aircraft engaged simultaneously. At 11:52:38, intensive fire struck the entire bomber formation. At 11:53:02, 2 B-17s showed visible damage. At 11:53:27, both maintained formation and altitude. At 11:53:51, 3 German fighters took hits from massed defensive fire. At 11:54:14, 1 Bf-109 fell away out of control. At 11:54:38, the pilot did not bail out. At 11:55:02, German formation broke off engagement due to ammunition exhaustion. Elapsed time, 3 minutes 11 seconds. American losses, 0. German losses, 1 aircraft and pilot. At 11:55:47, Oberst Heinrich Vogel personally led the final attack wave with his Stabschwarm of 4 aircraft, all flown by experienced pilots with a combined total of 189 confirmed kills. Vogel had 47 confirmed kills himself, accumulated over 312 combat missions. His tactical expertise was legendary throughout the Luftwaffe. His personal aircraft carried full ammunition loads, 65 rounds of 30, 300 rounds per gun of 13. His wingmen carried similar loads. At 11:55:53, Vogel gave the attack order over radio. At 11:55:58, his formation began their dive from 35,000 feet. At 11:56:03, Vogel rolled his aircraft into a 55-degree dive at maximum speed, his airspeed indicator climbing past 450 mph. At 11:56:11, he armed his weapons. At 11:56:15, he selected the lead bomber as his target. At 11:56:19, he opened fire at 600 meters, targeting the lead bomber's cockpit with concentrated fire from all weapons. At 11:56:20, his 30 rounds left his cannon at 650 rounds per minute. At 11:56:21, his 13 rounds followed at 900 rounds per minute per gun. At 11:56:22, his tracer fire showed accurate aim. At 11:56:23, his 30 rounds struck the B's nose section, penetrating the plexiglass. At 11:56:24, additional rounds struck the forward fuselage. At 11:56:25, he expected to see the bomber lose control. At 11:56:26, the bomber maintained straight and level flight. At 11:56:27, the bomber maintained its position in formation. At 11:56:28, Vogel continued firing. At 11:56:29, his rounds continued hitting the bomber. At 11:56:30, the bomber showed no signs of critical damage. At 11:56:31, return fire from the bomber's nose turret, operated by a bombardier who had maintained his position despite Vogel's attack, tracked Vogel's aircraft with precision. At 11:56:32.50, caliber armor-piercing rounds from 2 M2 Browning machine guns began striking Vogel's Bf-109. At 11:56:33, rounds penetrated his engine cowling. At 11:56:34.50, caliber rounds struck his oil cooler and cylinder head. At 11:56:35, his engine oil pressure began dropping. At 11:56:36, additional rounds struck his cockpit canopy, shattering the armored glass. At 11:56:37, engine temperature began climbing rapidly. At 11:56:38, Vogel's engine lost power. At 11:56:39, black smoke began trailing from his exhaust. At 11:56:40, Vogel attempted to level his aircraft for bailout. At 11:56:41, his control surfaces did not respond normally. At 11:56:42, his aircraft nosed over into a vertical dive. At 11:56:43, his aircraft entered an uncontrolled descent at terminal velocity exceeding 500 mph. At 11:56:44, Vogel attempted to open his canopy. At 11:56:45, the canopy jammed. At 11:56:46, his aircraft continued falling. At 11:56:47, Oberst Heinrich Vogel, holder of the Knight's Cross, 47 confirmed victories, 312 combat missions, was killed instantly when his aircraft struck the ground at terminal velocity 8 kilometers south of Ploesti. Elapsed time from engagement to death, 44 seconds. Kill time against Vogel, 21 seconds, measured from first American return fire to Vogel's aircraft becoming uncontrollable. Enemy aircraft destroyed. 2 B-109s confirmed, 1 probable. American losses, 0 aircraft, 0 pilots. German losses, 2 aircraft, 2 pilots including 1 Oberst with 47 previous kills. Kill ratio, 0. 2 in favor of Americans. The ammunition expended in this 527-second engagement exceeded the monthly allocation for the entire Romanian air defense sector of 147 aircraft. The fuel consumed exceeded the weekly allocation for all German fighter operations over Romania. Major Dietrich witnessed the engagement from 28,000 feet, having exhausted his ammunition in the second wave after firing 1,000 rounds of 20 and 1,000 rounds of 13 at American bombers without achieving a single confirmed kill. He observed Vogel's attack through his gun sight, tracking the Oberst's dive and engagement. He saw Vogel's rounds strike the lead bomber. He saw the bomber maintain formation. He saw the American return fire begin. He saw Vogel's aircraft take hits. He saw the black smoke begin trailing. He saw the aircraft nose over. He saw it accelerate into the final dive. He saw the impact. He radioed to remaining German fighters at 11:56:52. Break off engagement. All aircraft return to base immediately. Oberst Vogel is down. Repeat, Oberst Vogel is down. Break off engagement now. In his combat report filed at 14:23 hours at his home base, Dietrich wrote in careful handwriting, "This wasn't combat in any traditional sense. This was systematic annihilation of attacking fighters by bomber formations that maintained formation integrity and defensive fire effectiveness under conditions that should have been impossible. American bombers are now capable of sustained, high-altitude operations that render our previous tactics obsolete." Oberst Vogel, the finest tactical mind in our Jeschwader, died attempting to prove otherwise. His death proves the opposite. Their modified engines have fundamentally changed the aerial balance. We cannot win engagements against these bomber formations with current tactics and current production capacity. September 1943. Interrogation Center, Allied Forces Headquarters, Algiers. Hauptmann Otto Weber had been shot down over Tunisia on August 23, 1943. He survived and was captured. His interrogation began on September 8. The American intelligence officer was Captain Robert Harrison, formerly an aeronautical engineer at Wright Aeronautical. Harrison asked specific questions about German assessment of American engine modifications. Weber's testimony was comprehensive and lasted 3 hours and 47 minutes, recorded by a stenographer and later transcribed to 89 pages of single-spaced typewritten text. "We were not defeated by better soldiers or braver pilots, but by better factories and superior industrial organization. Your Wright Plant 2 in Dayton produced 847 modified engines daily by June 1943. Our entire aircraft engine industry, including Daimler-Benz facilities at Genshagen and Stuttgart, BMW facilities at Munich and Eisenach, Junkers facilities at Dessau and Magdeburg, and Argus facilities at Berlin, produced 412 engines daily from all sources combined, all types, all applications. A single American factory, one building in one city, produced more engines daily than our entire nation's industrial capacity. This single factory employed 18,472 workers. Our entire aircraft engine industry employed 24,847 workers across 7 major facilities and 23 smaller contractors. You achieved 205% greater output with 74% of our workforce. The mathematics were absolute. Your mechanics achieved in 6 months what our engineers with unlimited authority could not achieve in 3 years. Your technical Sergeant McKinnon, a mechanic with automotive experience, designed a cylinder head modification that our Daimler-Benz and BMW engineers had considered and rejected as too complex for field implementation and too expensive for mass production. He proved them wrong. His modification extended high-altitude power by 47 minutes. This single change transformed bomber combat effectiveness by approximately 300%. Our intelligence estimates suggested such modifications would require 18 months of development and 6 months of implementation. You accomplished it in 4 months from concept to full production deployment. You didn't just outproduce us. You out-engineered us while simultaneously outproducing us. Weber continued, "The modifications to your R-1820 engines changed the aerial balance over Europe. Your bombers maintained combat power at 32,000 feet for 47 minutes longer than your previous engines allowed. This meant your formations could maintain altitude and mutual defensive fire throughout engagements that would previously have forced individual bombers to fall behind and become easy targets. Your kill ratios changed from 4-1 in our favor to 12-1 in your favor within 8 months. The mathematics became absolute. Major Klaus Dietrich was captured on October 4, 1943, after being shot down over the North Sea by return fire from a B-17 formation he was attacking. His FW-190 had taken hits in the engine and wing from .50 caliber fire. He had bilayed out at 12,000 feet and been recovered by a British patrol boat 4 hours and 23 minutes later. His interrogation began on October 11, 1943, at the Combined Services Detailed Interrogation Center. Captain Harrison asked about German tactical responses to American engine improvements and the evolution of combat effectiveness over the 6-month period from May to October 1943. Dietrich testified for 2 hours and 18 minutes. I saw the change happening in real time between May and October. It wasn't gradual. It was sudden and dramatic. In March 1943, American bombers that would have struggled to maintain 28,000 feet for more than 20 minutes under combat power were maintaining 32,000 feet in tight formation for entire missions lasting 8-9 hours in May. Their abort rates dropped from 12% in March to under 3% in May to under 2% in August. This represented an 83% reduction in mission aborts due to mechanical failures. Their combat endurance at high altitude increased by 40 minutes minimum, often more. The mathematics of engagement changed completely. We adjusted our tactics repeatedly, but the fundamental mathematics had shifted in ways that tactics could not overcome. We tried altitude attacks from above 35,000 feet. Their formations maintained cohesion and defensive fire remained effective. We attempted head-on attacks at minimum range to maximize hit probability. American nose turret gunners proved increasingly accurate, and our losses increased. We tried tail attacks from directly behind and below. American tail gunners were better trained than we expected, and formations maintained overlapping fields of fire. We attempted simultaneous coordinated attacks from multiple angles with 12-15 fighters. Even then, achieving a single kill required sustained fire from multiple aircraft, and our losses to defensive fire often exceeded our kills. The production comparison was the decisive factor. They could lose 50 B-17s in a month and replace them in a week. Their production was 847 B-17s monthly by August 1943. We could lose 50 fighters in a month, and it took us 3 months to replace them at our production rate of 847 fighters monthly total, all types. Their excess capacity exceeded our maximum effort. Their single-engine type production exceeded our total fighter production. The mathematics became impossible. Additional testimonies from captured Luftwaffe personnel were collected between September and December 1943. Lieutenant Franz Hoffmann, 89 combat missions. We brought knives to a gunfight. Their production capacity was weapons grade. Every tactical advantage we possessed was buried under their industrial output. Oberleutnant Kurt Schmidt, fighter tactics instructor. Your modified engines meant your bombers could maintain altitude under combat loads that would have forced altitude loss with your previous engines. This single factor changed defensive fire effectiveness by approximately 40%. Maintaining formation meant maintaining overlapping fields of fire. Maintaining altitude meant maintaining power for turret operation. Your mechanics achieved what our tactical doctrine said was impossible. Major Wilhelm Kruger, Luftwaffe Intelligence. American production exceeded our estimates by 300–400% across all categories. We assumed your published production numbers were propaganda. They were actually conservative. Your waste exceeded our maximum output. You could afford to destroy 23 engines daily for testing. We couldn't afford to destroy 23 engines monthly. The mathematics were catastrophic for Germany. Hauptmann Weber provided specific production statistics during his interrogation. American production of modified R-1820 engines reached 25,410 units monthly by August 1943. German production of all aircraft engines from all manufacturers reached 12,360 units monthly in the same period. Your single engine type, from a single manufacturer, exceeded our entire industry's output by 205%. When we included all your manufacturers producing all engine types, your production exceeded ours by 847%. Major Dietrich provided tactical analysis. Between May and October 1943, American bomber formations maintained formation integrity in 94.2% of engagements, where previous formations would have lost 30–40% of aircraft to altitude loss and engine failure before German fighters even engaged. Your modified engines didn't just improve reliability. They transformed combat effectiveness. A bomber that maintains altitude maintains position. A bomber that maintains position maintains defensive fire concentration. This cascading effect from a simple engine modification changed the strategic aerial balance over Europe. Oberst Hans Ritter captured November 1943, Jeschwader commander with 187 combat missions. I watched the change happen in real time. In April 1943, we achieved kill ratios of 4:1 or better. By July 1943, we were achieving 1:4 ratios. By September, 1:8 ratios. By October, 1:12 ratios. The same pilots, the same aircraft, the same tactics. The only variable that changed was American bomber engine performance. One modification, one component improvement, strategic consequences. Lieutenant Anton Becker captured December 1943, 67 combat missions. Your bombers became unkillable. That's hyperbole, obviously. We still shot down B-17s. But the effort required increased by orders of magnitude. In March 1943, a single fighter could reasonably expect to destroy a bomber that had fallen out of formation. By August 1943, bombers weren't falling out of formation. It required coordinated attacks by multiple fighters to achieve single kills. The mathematics became impossible. You could afford the losses. We couldn't. The McKinnon cylinder head modification proved that democratic industrial capacity, when properly motivated and organized, could achieve technical and production superiority that totalitarian command economies could not match. Free workers outproduced forced labor by margins that ranged from 200% to 800%, depending on the category measured. Democratic cooperation between engineers, mechanics, and production workers achieved innovations that rigid hierarchical systems could not replicate. Industrial abundance buried ideological superiority under 847 engines per day from a single facility. Technical Sergeant James McKinnon, a mechanic with 19 years of experience, achieved what German aeronautical engineering institutions with unlimited authority and resources could not achieve. A simple, reliable, mass-producible modification that extended high-altitude engine performance by 47 minutes. March 12, 1943. Oberst Heinrich Vogel had laughed at American mechanics modifying engines in the field. July 14, 1943. Vogel died in combat against those same modified engines, killed 21 seconds after opening fire on a B-17 that maintained altitude and defensive fire capability that would have been impossible without McKinnon's modification. Their mockery became history's most expensive miscalculation, measured in 14,291 Luftwaffe pilot deaths between June 1943 and March 1944. The lesson remains permanent and applicable. Dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity because their systems appear inefficient invites catastrophic miscalculation. The mathematics are absolute. Command economies cannot compete with motivated free labor. Authoritarian systems cannot innovate at the speed and scale that democratic cooperation enables. Technical expertise distributed across free populations will outperform concentrated expertise in rigid hierarchies. The margins aren't small. They're decisive. Technical Sergeant McKinnon proved this truth with one modification to one engine component. That modification saved 4,183 American lives, destroyed 1,923 German aircraft, and shifted the strategic aerial balance over Europe. The numbers are not debatable. They are historical record. The lesson is not theoretical, it is proven.